Same idea. Cosine negative 210. Cosine negative 210. I first find my reference angle for negative 210. I go the other direction. Here's 180, 30 degrees more. Okay? So that means that the reference angle here is 30 degrees. Okay? The reference angle, to find that from this quadrant, remember, it's going to be theta minus the 180. Yeah, what do you got to come back around? In the first quadrant, 30 degrees has the ordered pair root 3 over 2. Remember, 3, 2, 1, and 1, 2, 3. It's the first angle. In the second quadrant, the x value is negative, the y value is positive. Once again, I am looking to identify what the cosine is. Cosine is the x-coordinate. The x-coordinate is negative root 3 over 2. Okay? It's all about knowing the first quadrant and bouncing everything out of there. What other ones do you want to look at as far as degrees are concerned? I have no problem doing a couple more if there's a particular one that was driving you nuts. On 47, we're cosecant negative 240. The cosecant negative 240. So first thing we do is we figure out where negative 240 degrees lines up. Here's 180. Go up another 60, and there's my 240. Which means my reference angle is 60 degrees. Do you agree on that? When I go to the first quadrant, 60 degrees has the ordered pair. Well, it's the third angle, 3, 2, 1, so it's 1/2. And it's 1, 2, 3, root 3 over 2. In the second quadrant again, the x value is negative, the y value is positive. And cosecant is the inverse of what trig function?
No.
Sine. You can get there eventually, right?
Well, because cosecant and cosine, it makes me think they're the same.
Yeah. Cosecant is the inverse of sine. So the cosecant of negative 240 is going to equal, well, the inverse of the sine here, it would be 2 over root 3. Well, we don't like that. We like 2 root 3 over 3. So you identify the sine or a cosine, whatever it may be, first, then flip the fraction and simplify. Yeah, Vanessa.
Okay. Sine,
Other way. Cosine, sine. Remember, what comes first in the alphabet, cosine or sine?
okay, so what I think so like sine rather than like y or x or r or something.
It is.
But it's always a
Well, what's the r value in the unit circle? 1. So root 3 over 2 divided by 1 is root 3 over 2.
okay, so you just take like x and y and
Correct. Correct. Because sine and cosine, the sine values are always the y value. Cosine is always the x value. Because you're right. Because the other day we talked about sine was y over r. Cosine was x over r. In the unit circle, your r value is always 1. That's why we don't change it.
so we're gonna have to remember the over r thing. Or just
Yeah, you will have to know that because you'll have to find sine and cosine of values that aren't on the unit circle like we did in the beginning before we got to the unit circle. Okay. Yes, ma'am. Yes, we can.
48 there is.
We can have tangent stuff.
48.
There's a problem like that in here. 48. Tangent 210. Tangent of 210 is that same idea. First thing we do is figure out where 210 is. It's third quadrant. It's 30 degrees off the x-axis. Okay? So that means its reference angle is 30 degrees. 30 degrees is the first set of ordered pairs, so it's root 3 over 2 and 1/2. Now, tangent, like you said earlier, tangent is y over x. So here you wind up with 1/2 divided by root 3 over 2. You get a complex fraction. Just rewrite it horizontally. 1/2 divided by root 3 over 2, which is 1/2 times 2 over root 3. And you wind up with 1 over root 3, which is root 3 over 3. Cosine is x. Tangent's always going to be y over x. Okay? And just remember, Vanessa, I know you're trying to figure out where this r comes in. In this instance here, when we're dealing with the unit circle, r is always 1. On some of the other ones, when we had to solve for r, that's when we were given the ordered pair, 5 and 7. You had to figure out what r was to start with, so you had to figure out how big the circle was in order to make the trig functions work.
But so these are going to be always over 2.
Yes. Because of the, if you remember how we did that with the special right triangles. Opposite, hypotenuse, all that kind of stuff. Okay. All right. Let's look at, are we okay on degrees then? Yeah. All right, let's look at radians. Remember, we'll look at the inverse. We'll look at the regular ones before we go to the inverse ones. Let's do the 2 regulars before we worry about the inverse. So we have the sine of 5 pi over 6. Sine of 5 pi over 6. Well, let's figure out what the reference angle is first. 5 pi over 6 is almost 1 pi. Do you agree? It is how far off the x-axis? Very good. It is pi over 6 off the x-axis. Does that make sense? So that means its reference angle is at pi over 6. Pi over 6 is the first set of ordered pairs. The first set of ordered pairs are root 3 over 2 and 1/2. In the third quadrant, the ordered pairs are both negative. Since I'm looking for the sine value, sine is the y-coordinate. The y-coordinate at negative 5 pi over 6 is negative 1/2. So your answer, negative 1/2.
So do you have to put it into like 5 or 6?
If it gives you in radians, keep it in radians. Because half these problems, that when you get these types of problems, you won't have a calculator. It will be non-calculator. You'll have to be able to calculate.
Is it 5 pi over 6 in the second?
If it's positive, in this case it's negative, so you want the other direction.
So, I'm saying all that 30 degrees is 5 or 6.
Yep.
Wait, I think my problem is that I can't find the reference angle.
Remember, your reference angle is always, always, always going to be how far away are you from the x-axis. Okay?
Okay.
So if you're in the first quadrant, that you are your reference angle. Second quadrant, it's 180 minus whatever your angle is. Third quadrant, it's angle minus 180. And then fourth quadrant, it was 360 minus the angle.
Right.
Or if it's in terms of radians, it's pi, or 2 pi. Okay? That's how that works. Your reference angle always bounces you to the x-axis. How far are you away from the x-axis? That's how the reference angle works. Okay. Cosine, 5 pi over 3. Let me get a clean sheet. So cosine of 5 pi over 3, well, 3 goes into 5 how many times? Once, and then there's how much left over? 2/3 pi. So here's 1 pi, and then 2/3 pi, is that more than halfway? Yeah, 2/3 is more than halfway. Okay? That means how far am I away from getting to 2 pi? I'm not 3, it's 1/3. Oh, I see what you're saying. I am, well, yeah, 30, it's actually 60.
That's what I'm saying, like, if it's just like a sketch like that, like, how are we supposed to know, like if it's 36 or
Okay.
45?
Do you agree that this is 1 and 2/3 pi? To make this, do you agree that this right here is 2 pi? Okay. What is 2 minus 1 and 2/3? What I'm doing is I'm just saying that because I'm doing a quick fraction. So I've already gotten rid of 1 pi. So 1 minus 2/3 is 1/3. That's all I'm figuring out here. This reference angle is 1/3 with a pi involved. What's pi over 3? How we would say it. Okay? Or since you have 5 pi over 3, you figure out where it's going to wind up. If you are in the 4th quadrant, you take 2 minus 5/3 in your calculator, math, enter, enter, slap a pi next to it. There's your reference. Okay. Calculator will do the work for you if you're having problems with fractions. Why 2? Because I'm in the 4th quadrant. To get the reference angle, it's 2 pi minus theta. Okay. So since my reference angle is pi over 3, in the 1st quadrant, pi over 3 is 1/2 and root 3 over 2. Remember, 3, 2, 1, 1, 2, 3. In the 4th quadrant, x is still positive, y is negative. And since I'm trying to find the cosine is the x coordinate. What's the x coordinate? 1/2. I think it is 1/2. What's the other one here? Cotangent and secant. Let's look at these two guys. Cotangent 11 pi over 6. Okay. Cotangent 11 pi over 6. 6 goes into 11 how many times? Once. How many are left over? 5. So this is 1 and 5/6 pi. How much pi do I need to create 2 pi? 1/6. So that means my reference angle is pi over 6. In the 1st quadrant, pi over 6 is the 1st angle. The 1st angle has an ordered pair of root 3 over 2 and 1/2. So in the 4th quadrant, x value is the same, y value is negative. It is asking for the cotangent. Cotangent is the inverse of tangent. So cotangent, this goes back to the x's and the y's, is x over y. So x over y in this case is root 3 over 2 divided by negative 1/2. And all I did here, instead of writing it as a complex fraction, I'm just writing it automatically horizontally. Because now I can multiply by my reciprocal. The 2's drop out, I'm left with negative root 3. There's my cotangent. Okay. Tangent is y over x, cotangent is the inverse. Okay. And then lastly, secant 23 pi over 6. I'll do this one, 23 pi over 6. We ask the same question. 6 goes into 23 how many times? 3, and how many are left over? So it's 3 5/6. So we got to figure out where we wind up again. 1 little, 2 little, 3 little pies. 5, 6, 5. What's my reference saying? Over 6 pi. My reference angle again is pi over 6. I go to the ordered pair for pi over 6, root 3 over 2, 1/2. Third quadrant, root 3 over 2, negative 1/2. Secant is the inverse of what function? Cosine. So I have to take the inverse here. So it's 2 over root 3, which is 2 root 3 over 3. It's the inverse of the cosine. Cosine equals root 3 over 2. So you flip it.
Like, so the sign.
Sine? No. Okay? Hold on to this. These are going to help you with what we do tonight. Because we're working backwards tonight. Okay? We're going to work backwards. Let me pause these